All right. So welcome everyone to how to start developing on Stellar. My name is Tyler Vanderhoeven. I'm the ecosystem engineer at the Stellar Development Foundation. I've been around for a long time in the Stellar ecosystem, been at the SDF for about a year and a half. It is my job to do lots of documentation, do workshops. I have three main projects around funding. Two projects around funding, the Stellar Community Fund, and then also Stellar Quest. And then I help build and maintain a smart contracting layer 2 solution for Stellar. But today we're going to kind of be backing it up a little bit to some fundamentals on Stellar to help you guys get your footing as you build Stellar applications. So taking it back to the roots. So the agenda today, we're going to just intro a little bit. Hopefully you've already gotten a little bit of Stellar background, but I'm going to be talking a little bit about the Stellar stack, how these things interact with each other, the different bits and pieces of Stellar. And then we're actually going to talk a little bit about Stellar SDKs and demystify what the Stellar SDKs are and how they relate to the Stellar stack. Then we're going to do a little bit of coding there, just some very basic stuff with a Stellar JavaScript SDK. And then we're going to talk about delegated signing methods. So how you actually get transactions signed within Stellar without having direct access to secret keys. So this sort of non-custodial version method of managing secret keys. And around that, we'll build a very basic application that implements both the SDK, the JavaScript SDK, and this delegated signing method. And then we'll open it up for any questions. Once again, I'm Tyler Vanderhoeven, ecosystem engineer. And I'm going to make sure I am disconnected from that channel. All right, so Stellar has several different layers here. A lot, as with any blockchain, you've kind of got this core synchronization layer that ensures the distributed database state is all in sync, so that anytime you ask a question of the blockchain, you're getting the same answer no matter what node you're asking the question of, or anytime you push an update. It's kind of the beauty of the blockchain. You're able to keep a database state in sync across many different nodes without having any single party having control. So that's the core of a blockchain, and that's no different for Stellar. The thing that can be different or is interesting a lot of the times where changes start to happen or where you may have differences is how you interact with that core. How do you get information into and out of that core? With Stellar, we have a API layer called Horizon. And so there's an application layer that sort of sits between applications, the things that you build, how you interface with core. There's this intermediary party called Horizon that makes interacting with the backend much cleaner, easier, intuitive. So no matter what kind of SDK or language you're using, there's a common set of functions for querying the database, the core database, decoding all of the XDR encoded strings into usable JSON endpoints, et cetera, et cetera. Horizon, so Stellar is a network of nodes, and then Horizon is also this application layer. It doesn't directly interface with other Horizon endpoints, but it's like a reference implementation for how to make this connection between applications and the Stellar core. So there'll be several different public horizons. You might choose to run private horizons yourself if you need to write custom queries or ensure uptime, things like that. You'll want to set up your own horizon as that connection point into core. Most of the time, you can just use our public horizon endpoints. We have both testnet and public network horizon endpoints, so you can query those yourself. But as you start to move towards more production level applications, you may want to look into standing up your own horizon. So in between kind of these arrows between your application and horizon, you've got code. You need to somehow interface with the Horizon API endpoints and your application. And this would be similar to if you're dealing with like the Stripe SDK, at some point it's dealing with ACH APIs and stuff that you never touch. They've written all of their sort of Horizon, their version of interfacing with those things. And then you interact with that through their SDKs, through their different libraries for different languages. And again, Stellar is no different. We have multiple SDKs stood up and maintained, whether that's internal SDKs like the Java and JavaScript. I think also the Go, actually it may just be JavaScript and Go that are officially supported, but our community has stood up quite a few other SDKs that are all very stable and are constantly maintained. So there's a really good large selection of different language SDKs that then directly interface with Horizon. So these are often the things that you're going to want to use. There's no requirement to use an SDK. Again, it's just a package. An SDK is kind of the idea of packaging up common functionality into really clean methods and functions so that since everybody is calling the same endpoints and doing the same things, you bundle those up together into a nice clean SDK to reduce code bloat and also ensure reliability, and everybody's updated. You only have to update one code base instead of 10,000 every time that there's like a protocol update or some vulnerability that needs to be patched, things like that. By having a single source that everybody works on, you create a lot of stability, security, and just ease of use, so that when you're writing documentation, everybody's dealing with that same SDK, same methods, same functions. And then it also gives that direct connection into a specific programming language. We'll be working with the JavaScript one today, but there's lots of others that you'll want to take a look at depending on what your language specifically is. But most of the functions are named similar things, so documentation is going to pair pretty closely between the different SDKs. And that, again, being a feature of dealing with that singular Horizon implementation of connecting between core and Horizon. By having that third-party layer, you get a lot of consistency between the SDKs. We'll be dealing with this JavaScript SDK, and I'm going to start screen sharing over on my browser here in a minute where we can actually look at these URLs, but feel free to screenshot these or write them down. They're not that hard to find, but you'll want to pull these up whenever you're actually programming in the SDK. This is one that a lot of people don't actually realize exists too quickly. They go right to the documentation, which is actually documentation for interfacing directly with Horizon. If you're interfacing with Horizon through an SDK, you need to find the SDK specific documentation. That'll help you a lot with the different methods and parameters that each function has. And then finally, after the SDKs, we'll be doing some delegated transaction signing work. We'll be using Albedo. So if you've ever used like MetaMask or other of these like Chrome-based wallets, plugin-based wallets, where you manage your keys and then transactions get signed through permissions, we're going to be using one of the Stellar ones. There's quite a few different ones, but one of my favorites is albedo.link. And this is a really good way to get transactions signed without having to control access of user secrets, which is pretty important. All right, so let's code. Let's go ahead and get right into it. I'm going to stop sharing this and move over to this. And I'm actually going to pull up my developers documentation right here. So if you go to the Stellar docs, developers.stellar.org/docs, you've got a nice software and SDKs link here that's going to show you all of the different SDKs. They're supported with links to docs as well as the open source docs if you ever wanted to dig into the code for any of these or need to submit issues or PRs for updates, things like that. So this will be a nice reference point for any of the languages that you're using. Again, we'll be using the JavaScript one, so I'm going to go ahead and pull open the source and the docs for these. I really need to move. There's a tab here that I need to get out of my way. So this is the JS SDK docs, and this is the JS SDK GitHub. So any issues that exist here, as well as any pull requests, as well as links to other documentation or requirements when installing on different platforms like React Native, etc. As well as some dependency information. There's actually a Stellar base. So Stellar SDK is going to wrap up a lot of your individual API requests. So actually make API requests to Horizon, whereas Stellar Base just composes transactions, which is actually really helpful if you're deploying onto something that needs to use a very specific type of API request. I mention it because I've been doing a lot of work with Cloudflare workers lately, which use a Node V8 or a Chrome V8 isolate. Which doesn't allow for arbitrary, I think the Stellar SDK uses Axios library, but Cloudflare Workers requires fetch. They've got their own special kind of packaged HTTP library. So Stellar Base allows you to compose all of your transactions, and then you actually make raw HTTP requests through their fetch method. So it's important to know that there are two different kinds here, one that kind of wraps up everything, and another one that's just the composition SDK. Won't be spending too much time there. We'll be doing a little bit in the actual JS docs. But first, let's actually jump into a run kit. So we're going to spend a little time in run kit just exploring the JS SDK. And I haven't put in a bunch of dummy code. I like to kind of start from ground zero and build my way up so that you see exactly what's going on. Sometimes that means things will take a little bit longer because I'll run into issues myself, but we'll wrestle through it together. What I'd like to do is compose a transaction for a specific account, or maybe a brand new account, and then we'll make some sort of arbitrary payment, and then we'll need to get it signed. So we're going to go through this whole process of using the SDK to generate a transaction, get it signed, and then submit it to the network. And we'll be building off of testnet. So we'll pull open our laboratory here to get some information as we need it. But let's go ahead and get started. The first thing we need to do, since we're using the SDK, is to set up the server connection to the actual Horizon. And for this, there is a server class. So we'll look up the documentation for that real quick. I'm going to pull this over just a little bit. So if we do a grep for server, we'll see our new server. We need a server URL and then some options, which we don't need to include in the options because they're optional, but we do need to include a server URL. So new server, and the server URL is just the Horizon base API that we're using. And like I mentioned, we can go ahead and use this testnet one. All right, so now we've got server. We can, from there, let's go ahead and spin up a new key pair. So like all of the blockchains, there's the idea of accounts, account strings. Stellar's got its own. So to be able to interact with creating accounts or making payments, everything kind of revolves around the idea of account addresses, which in this case are denoted as key pairs. So it's that ACE, I can't remember the term, the kind of cryptography where you've got a public key and a private key, and that together combined is called a key pair. So we're going to create a new key pair, and we're just going to create a random one. So if we go here and we grep for key pair, there's a method on here called random, which will generate, you guessed it, a random key pair. And if we just go ahead and console log that, we're not using server at the moment, but if we look at that key pair, it's going to give us a lot more information than perhaps we actually need for doing much of anything. But we have some nice buffers creating key pairs or secret keys, public keys, secret seeds, gives us the type, et cetera, et cetera. If we want to go ahead and look at what our new public key is, we've got a method called public key. So there's a whole bunch of methods on these. We can get our random, and then if we can get the secret, we can sign stuff, we can verify data, we can get the public key, and that's the one we're actually using right now. So it'll take that buffer and decode it into its public key counterpart. Now, if we were to take this and say, oh, sweet, I've just made myself a brand new public key. Look at me. If we look that up on the blockchain, we'll notice that it's 404. It's a valid key pair. It does not exist on the blockchain yet, because otherwise I could just make an infinite loop of random key pairs and blow the blockchain up. So to actually get it on the network, we need to generate a valid key pair, but then we actually need to fund it. And since we're on testnet, there's a nice little helper. I think it's called FriendBot. I'm not sure that it's actually exposed here, which is why having our direct SDK can be nice sometimes. I think there's a method called FriendBot. I don't remember exactly what it is. It might be FriendBot call or something like that. But there's also another nice little trick you can do. So what we just did was generate a key pair. So I can do that exact same thing here, blah, blah, blah. But none of those actually exist until we, in this case, use FriendBot to actually fund it. So this is going to put the account onto the blockchain as an actual account. So a nice little trick that we can use is actually inspecting the XHR requests that are going out from the Stellar laboratory. And then we can use that endpoint that it's hitting, and we'll just, we'll snipe that for our purposes. So I'm going to pull in node fetch. And then instead of using the FriendBot helper, we'll actually just make a raw fetch request and fill in this with our public key. So I'm going to set that to a variable here. Pop that in there, and then we'll do a then. We need to get this request back. Also going to await this so that if it throws, we can catch the error. And then if the result is okay, we will return res.json. Otherwise, we will throw the result. So that's going to take this public key, send it to FriendBot, and return the results. We indeed did fund this brand new account. Now, instead of every single time this runs, creating new public and private keys, I'm actually going to also save the secret so that I have both of these. And then I'm going to console.log these really quickly. And then I'll change my code to not do a random, but to actually pull in the account that already exists. So secret key and public key. So this is our secret key. And this is our public key. And then we don't need to generate random anymore. What we need to do is const key pair equals key pair from secret. And then we'll use the secret. And this will generate the exact same key pair, but instead of it being random, it'll match up to this private public key. And then we don't need to fund it anymore. We'll notice one thing first, that our secret and public key are obviously going to be the same because we hard coded them. But the next thing we'll notice is this should throw because we've already funded this account. So with any luck, we'll get a nice little error that's super unhelpful. let's go ahead and get the body from that. And that should give us a more helpful error if we rerun this. Hello? There it is. Create account already exists. So we've already created account. So I'm going to go ahead and comment that out because we don't need it. And now we can finally start moving on because our account exists. So if we take our public key and we go and look at the blockchain over on our Explorer account endpoint, if we submit that, we should see that we actually have an account now. And FriendBot should have given us 10,000 lumens. So we've got a nice clean 10 grand of lumens sitting in the bank. We can now begin to run some actual commands. So like the one that we just ran right here, this command. So if we again do an XHR inspection on Git, we'll see that we made a GET request. We can actually just call that straight in the browser if we wanted to, and it'll return a nice piece of JSON for us. But I actually want to do that in code. So there's a method called load accounts, and we'll load up the public key, and then we will return the account. And that'll give us an account response along with information from the SDK about the account. So you can see we've got our balances here. We've got our 10,000 limits. So it's starting to look pretty similar to what we just saw on the JSON. It does have some nice helper functions around getting things for the account, like its operations, payments, etc. So it has some additional things than if you just called it into raw JSON, which again is one of the reasons the SDKs are nice, is that you get these helper functions without having to recreate them all yourself. Okay, we've loaded up the account. Let's go ahead and start thinking about building a transaction. So to be able to build a transaction, what we need to do is start a new transaction builder. What in the world is a transaction builder? We'll take a look at that. First argument that it takes is an account. But before we get too much further, let's actually take a look at our documentation again on transaction builder. So transaction builder takes a source, which is the account, which we just pulled in from this load account. So we have this account variable, which will pop in there. Pull this over here. The next thing it takes is some operations like fee, time bounds, memo. Some of these, a lot of these are optional. The ones that I care about right now are the fee and the network passphrase. Make sure we're going to ensure that via our network passphrase that we're going to build a transaction for the test network. The fee, if anyone of you are familiar with Stellar, every transaction uses some small amount of lumens, every blockchain. This is the prevention, the spam prevention method. There are base fees for transactions, and Stellar's case for individual operations. So we're going to say what our base fee is. In this case, base fee equals 100 stroops. Set at the SDK level. You could manually set it yourself. But it's not lumens individually, it's stroops. So when you're looking at a lumen, it's made up of 1, 2, 3, 4, 5, 6, 7 decimal places. So 100 stroops would be that right there. So a stroop being the smallest amount that you can divide a single lumen by. The other thing that we needed was that network passphrase, which we can also, I'm going to go back to base fee for now, and that is a item you can grab. And if we look that up here, you'll see that that's set in the globals. Another one that's set in the globals is our networks. And I want to get networks testnet. So we're going to call this networks.testnet. So this would be a nice place where you could use global variables based on, I don't know, the node environment or something to toggle whether you're working in the testnet or the public network. But I'm going to go ahead and semi-hard code that to the testnet. All right, so now we've effectively begun our transaction building process. So now we need to begin adding operations to it. So I'm just going to hard copy this for now, give myself a head start. I'm actually going to take a look at the laboratory really quick. So if we were to go to transaction builder, you'll see a lot of these things replicated. Source account, that's kind of like setting that account that we initially did. Doing that in the SDK sets both the source account address as well as the sequence number for that account or for the transaction that we're building. There's our base fee. We can opt to add a memo if we need to, as well as time bounds, and then we begin adding operations. So that's the thing we're going to do right now. And the only thing we're going to do at the moment is actually make a payment. And for sake of example, I'm just going to make a payment to myself for 1,000 lumens. So if we go back here, we'll see, actually, I think we still got it right here. The ID, and there's also account ID for on the account object. So I'm just going to use the account ID as our destination, which essentially says, hey, me, pay me. So I'm going to take 1,000 of my lumens and pay myself those 1,000 lumens. I don't care about adding a timeout. Actually, I need to have some sort of timeout, otherwise the transaction will fail. So I'm going to set it to 0, which effectively says there is no timeout. This transaction is valid forever. If you wanted this transaction to be only valid for a certain amount of time, you would set the set timeout. If you wanted this transaction to only be valid after a certain date, you would include something along the lines of your time bounds, min time. So max time would be how long until it expires. Min time would be how long until it's actually able to be submitted. So there's some nice functions around that. If you've ever done stuff with like JWTs with the not before NBF or the EXP claims, that should be kind of familiar. The next thing, so I need to include our operations. I also need to include this asset class. So there's a nice, if we look at asset here, we should see this .native function, which essentially says, I want to use lumens as my asset. Operations also is a new one. Oops, just operation. Right here, there's just a bunch of these operations that we can set. Stellar is a non-Turing complete blockchain. We have only a very specific number of things that you can do, which allows us to be very cheap and very fast and very safe. There's a lot that you can do, and when you compose these things together, so you don't have, each individual transaction doesn't only include one operation, you can include up to 100 different operations in every single transaction, and it's atomic. So you can build some very complex logic around your transactions by composing any number of combinations in your transaction with all of these different operations. So just because Stellar's not Turing complete doesn't mean that it's not incredibly powerful due to its atomic multi-operational composability. Okay, so at this point, we should have a valid transaction. So let's go ahead and take a look at that. So we get a nice transaction object here with all of the different bits and pieces. At this point, it's getting close to being ready to be submitted. If we were to XDR this, I think this would take it and put it into an XDR format. So this is our encoding language that we use. We can actually inspect this XDR. So we'll see the source account is what we expected, this 37H from right here. Giving you all vertigo switching my tabs so quick. You see our sequence number has been set, and then we also have this payment. We're making a payment to ourselves for 1,000 lumens. If I were to try and submit this transaction, we're going to get the error that we don't have the authentication. So this is where the signing bit of the blockchain will come in. So before we can actually get this transaction signed, we're going to need to, or before we can get it submitted, we're going to need to get it signed. So the way we do that is simply transaction.sign. And if we look at at this point, it goes from transaction builder to, when you hit build on the transaction builder, it converts the transaction builder object into the transaction object. And there is a sign method on that, which takes a list of key pairs. So if we remember from up top, we took our key pair when we built it, and we can sign that transaction with the key pair. And now, if we console log our transaction to XDR, we should get a transaction back that includes a signature. Let me do the view. So if we look here, we've got, oops, it already pasted it for me. We've got our signature here at the bottom. So this transaction has been signed. And then if we go and submit this transaction, it should go through and make ourselves a nice clean 1,000 payment from ourselves to ourselves, which is going to result in a net loss of whatever the transaction fee was. So we'll go ahead and look up that transaction that it just spat out. Sure enough, it's successful. Doesn't give us any information about the operations. We can just click this little link up here and look up operations for this transaction. So here's the single operation record, and it was a payment from 37H to 37H for 1,000 XLM. So we've successfully created, signed, and submitted a Stellar transaction using the JavaScript SDK. Super duper. However, what if we wanted to not do this? Or maybe we didn't have access. Let's say we didn't have access to this secret key. We can still compose a transaction without a secret key, right? The only time we're actually using key pair is when I'm actually going to grep this to make sure I'm actually saying the true thing. The only time we use key pair is when we sign. So we can get a fully valid XDR without needing a secret key ever. The issue is this won't actually be submittable because it's not signed. So if you're in an application and your application backend is creating transactions for people, but you need to get these things signed, you have two choices. Either A, you need control at some level over the account where you have ownership essentially effectively over a secret key. So you can actually get things signed on behalf of your users. That's option A. Option B would be somehow your users have ownership over secrets, but you generate transactions and then they actually sign them on their end. This is my preferred method where you don't actually have the liability of having loads and loads of user secrets in your database. The users have those, but there has to be a nice clean interface for them to move from raw transaction to some sort of clean interface where they can sign. Because I don't think you want to email somebody probably this string right here and say, hey, copy this, pop it open in the Stellar Lab, click on submit transaction, or actually click on sign transaction, paste in that thing I sent you in the email, import that transaction, and then paste in your secret key, click. Let me actually do this because this is actually kind of interesting. I want to make sure I copied the right one. Import that transaction, then take your secret key, which you'll need the raw format of, and paste that into the signer piece, then click submit on the transaction submitter and submit the transaction. That's not a great flow. It works. We got our transaction submitted, but it's not a great flow. Wouldn't it be nice if there was an application you could use a la something like MetaMask, or in our case, Albedo, to handle that? So at this point, we're going to switch over. So I've got an Albedo account, and if I manage that account, switch over to my testnet, I've got my public key right here. So I'm going to build a transaction for the public key. I don't have enough lumens to really do anything. So I'm actually going to, the first thing I'm going to do is make a payment to this account so that I actually have a bunch of lumens. So I'm going to create a dummy account, which I already have it here. So I'm going to take this. I'm just going to really quickly build this transaction and make a payment so that that account actually has some lumens to do something with. Copy this. I'm going to add 5,000. We'll get that signed. To do. And now this Albedo account should have, 5,000 lumens in it. Super. So we're going to go back to our Stellar SDK, and rather than using this, I'm going to use this. And I'm going to use this account. I'm going to say, hey, I want this account to make a payment to itself for 1,000 lumens. Run this. So we've got our XDR, but how are we going to get this signed? I don't want to ask my user, this Albedo fellow, to actually paste in secret keys and move things around in laboratory. I want them to just be able to use our Albedo interface. For this, I'm going to switch over to this StackBlitz interface, where I've built a very simple application interface, this super duper web UI, where I've just got a text area where you're supposed to paste in an XDR. This isn't necessary. There's other things you can do here where they don't actually have to paste the XDR. Like you could send it in a URL string, for example, and read it in automatically. So you're in your email example, you might have an email link where the XDR was included as part of the URL. But for now, sake of ease, we're gonna just do a pasting in the XDR. So we've got this XDR and we need that signed and then submitted. So we've got a button here. The button, what does the button do? That's where our script.js comes in. I'm pulling in the Albedo script. So let's go back to albedo.link and we'll go down. Actually, I think, no, I don't have this pulled up yet. Let's pull up the open source library that he's got. There's a front end library here and an intent library. That's the one we're going to be using, the intent library. So if we go back to this platform here, inside my index.html, I'm pulling in the Albedo intent library, which will allow us to connect to this Albedo interface. And then there's lots of different methods and functions you can call for Albedo. And then in our script, the first thing I want to do, so we're pulling this Albedo. Let's just list, for now, let's just list the public key. So this is not going to do anything with this. This is just going to pull up this Albedo window. You can see I've got this account selected, and it's just going to read the public key information. So there's my public key. That's how I would validate that I actually have ownership over a public key. This is actually something that's really important to be able to do to prove that a user owns a specific public key. So by having a signature and a signed message, you can say, hey, did the secret key for this public key, based off the message that we have, actually sign this? Like, is this signature on this signed message the secret key for, or was it signed by the secret key given by the public key? So you could pass this whole object to the back end to prove ownership over a public key. Super important to be able to do. But that's not what we want to do. What we want to do is take the XDR coming from this text area. So I query select the text area, and then I also query select the button. I want to take this XDR value and I want to throw it into this transaction piece, this transaction function. So Albedo has a transaction method where you throw in an XDR, you specify the network you want it to be on, and then it will spit out a result. That's what I actually want to do. So the first thing I want to do is paste back in this unsigned XDR. Remember from here, I've made a request for a payment, but I need to get it signed. So Albedo is going to open up the interface. It's going to read this XDR, and it's going to give us a really nice interface where it's saying there's one operation, and it's a payment operation for 1,000 XLM, and it's going to be going to this 6P or 7P6A, which is this account right here. So it's just what we expected. It's running on the network, the test network. We're going to go ahead and confirm that. And what do you know? We get our signed envelope XDR right here. And if we go and we were to submit this, it should go through because we actually signed that XDR, which is fantastic. We've successfully used our delegated signing mechanic. Now there's two different ways you can do this. I'm going to go ahead and create a new one with a new sequence number. For all you pros out there, that's why this continually running this actually works, is using this account. When I grab it, actually bumps that sequence number so I don't run into issues with the sequence number. But I need to paste in a new one of these. You'll notice something changed. That right there apparently is our new sequence number. What if we wanted to submit this? So this is actually really nice that you can just get the signed XDR, because then you could send that back to your backend and maybe wrap it in a fee bump so that this user didn't have to pay their own fee. So this self-to-self payment, for whatever reason you'd want to do that. If you didn't want them to pay the fee, you could wrap it in a fee bump. So you would take their signed envelope XDR, send that back to your backend, and then your backend would actually wrap the whole thing in a fee bump transaction. If you didn't want to directly submit it. So you don't have to submit it. You can just sign it and then do something else with the actual XDR. But what if we actually did want to submit the transaction? We didn't care about fee bumping. We wanted to just submit it. We'll take our unsigned XDR. We'll sign and submit this. Now it's submitting to Horizon. And we should get our output, which instead of being just the signed XDR, we should actually get a result object, which includes information about the transaction that was actually signed and submitted. So we never have to know, never need to touch the secret key for this account. We can use this delegated signing method with Albedo to get that signed, submitted incredibly securely. All right. Well, these resources, I'll make sure to put links so that people can grab a hold of these and make clones of both the run kit and the stack blitz. I'm going to go ahead and see if I can figure out a way to get at any questions you all have for me. I suppose probably the best way is doing it in the actual Zoom chat. So I'm going to stop sharing so that I can get access to the Q&A. What browser is this supported in? Any browser, as far as I have tried. Albedo is actually really fantastic in the sense that it's not a Chrome plugin. It's a website, a client-side website only that you then access through either iframes or pop-ups. So it works depending on what your mobile platform provider is. You can use it in mobile applications. You can use it in any web applications. Anywhere where iframes or pop-ups are supported, Albedo should work. That's not true with all of the ones that I'm using. And I'm going to go ahead and just, I don't need to post those there. There's Freighter, which is a Chrome plugin, actually built by SDF. There's another one called Rabbit, which I also think may be a Chrome plugin. They tend to be more on the Chrome plugin side, but one of the reasons I really like Albedo is it's not limited by that. There are definitely some nuances around different browsers, but it's better than being locked into Chrome support only and then having to wait on some sort of native application or something. So that's super nice. Any other questions for me around delegated signing or the SDKs? Can this be used to do transactions in USDS? I don't know what USDS is, but if you meant USDC or any asset, really, doesn't really matter. Any asset on Stellar for sure. Because Albedo has their transaction. Albedo has a lot of different methods, but because they support the raw arbitrary transaction method, you can put any XDR. So if that XDR is dealing with any Stellar asset, it'll work just fine. There will need to be like trust lines and things opened, but so long as that information is included as an operation in the XDR that's being signed, it works great. I actually make heavy use of Albedo and all that it can do inside the Stellar Quest application. Stellar Quest transactions are actually pretty complicated. They're opening trust lines, they're making badge payments, they're making XLM payments. They're also doing sponsored reserves for trust lines as well as sponsored reserves for accounts. So the users never pay fees or base fees. So you can get away with a whole ton of stuff with Albedo. I have yet to be able to figure out how to appropriately break it. It does get a little tricky on the iOS iframe side because the way the communication happens between Albedo or the way that communication happens between iframes or, iframes in iOS mobile applications, they don't give you access to local storage. So all of the secrets are encoded on client side, which means they use local storage, but you don't have access to local storage in an iOS application. So you have to use like post send message to send the encoded piece from to send the message from the Albedo interface over to your application. So your application is actually storing all the information for Albedo, and Albedo just kind of fires up their interface from the storage on your device. It's pretty cool the way it works, but I actually had to work with Orbit Lens, who's the guy who builds and maintains Albedo, to get that functionality added to where you can almost delegate you can delegate the storage of Albedo to something other than the website itself. All the keys are handed over through a post message. Pretty cool. Is there an API service that you would recommend for converting to fiat currencies with Stellar, say USDC to USD or Euro? That's going to be the job of our Anchor network. So you'll need to look into what services are providing those conversions between individual Stellar assets and their real world counterparts. So taking some digital version, some stellarized version of some asset and a real world version of that asset. The same way you would do like in Coinbase, where you convert the Ethereum USDC to your actual bank account. Not every Stellar asset has a direct conversion. Not every asset needs a real world conversion. XLM doesn't have a real world counterpart. There's lots of assets like that. But for any asset that is issued that way, you'll just need to inspect look at the network to see where those anchors might exist. And looking at the TOML files on individual assets. So if you look up the issuer for an asset, looking at the TOML file could give you some information, some clues to see if there are anchor networks. Otherwise, asking questions in Discord to see if particular assets have a way to get from Stellar to a bank account, for example. What would be the steps to building an AMM or bridge? That's not a question that's very easy to answer because it's going to depend on the assets. It's going to depend on what your requirements or sort of outcomes are. Stellar is in the process of adding a cap to natively integrate AMMs into Stellar. Because Stellar is not Turing complete, adding DeFi protocols can be pretty tricky. If you're there, a lot of them actually aren't possible if you're doing them directly on Stellar. If you use a layer 2 solution like the Turing signing network, so if you go to tss.stellar.org, there's a protocol that I've been working on for about a year that adds this layer 2 arbitrary JavaScript or arbitrary programming language support, composability, Turing completeness to compose these transactions. But there's still issues around like real-time latency when you don't have a direct connection to the state that you're about to change or you're actually changing. Ethereum has both of those things combined together, both the creation and execution of transactions together. Stellar has those things separate, where you compose and execute transactions separately. And because of that, complex real-time DeFi things like AMMs, bridges less so, but AMMs would be really tricky, probably impossible to do without some sort of either side net, side chain, blockchain running alongside, or actually putting them directly into the protocol, which is what there are two CAP proposals saying 37 and 38 that are they're looking at adding AMMs directly into the core, so that something like that could happen natively. For bridges, again, it depends on, are you bridging from the real world to digital, or are you bridging just across digital to digital, like Ethereum to Stellar, depending on what the requirements and flow for those are. Again, that's kind of like an anchor process where there are crypto to Stellar, or like Ethereum to Stellar, other crypto assets to Stellar, where you've got like wrapped tokens and things. But the answer for that question is really dependent on what assets you're dealing with. And there are a couple of really good teams working on that. One of my favorites, if you go to communityfund.stellar.org and then look at the seed fund tab, we recently funded 8 projects, and one of them was Script3, who runs option blocks and yield blocks, which are building some DeFi protocols for lending and the trading platforms, more the types of lending protocols on top of the Turing signing network or protocol. That's super interesting. So the work that they've done, you can follow their blog and their Discord to get some ideas of how they're accomplishing these things using the layer 2 Turing signing network. What is the easiest thing to build? I don't know. It's a wallet's pretty easy, but you really shouldn't be looking for the easiest thing to build. You should be looking for the most useful, achievable sort of MVP. In my opinion, some of the projects that I think would be interesting that our ecosystem really needs are a continued effort on bringing good user experiences using the protocols that we already have. So almost building user interface SDKs to things like delegated signing. So there is Albedo and it works pretty well, but there's even more work that could be done on that front on delegated signing wallets, but really looking at protocols or interfaces that start to almost like connect assets that do have anchors already existing. So building out a platform for accepting USDC for any service online, or maybe a USDC plugin widget for WordPress or Shopify, so that individual companies could begin accepting Stellar USDC more easily. And then any conversion process that might be necessary. I think Lobster, one of the Stellar partners that builds a lot of products, particularly around USDC right now, they have a conversion from the Ethereum USDC to the Stellar USDC. There are integrations you could have there. There's also DStock APIs. There are Satoshi Pay APIs. A lot of these sort of Stellar APIs or Stellar partner APIs that are beginning to give you access to doing some really interesting things. So exploring some of those products could be really cool, as well as just things like low connectivity, which are more just general, not Stellar specific necessarily. But if you have low connectivity, how would you sort of pend a Stellar transaction or store a Stellar transaction for submission at a later date? Is there a good way to do coordination around that, where you don't run into a bunch of errors because of cross transaction or cross operation dependencies, where I'm spending too much here, but that could provide a lot of access to financial services for folks in low connectivity or no connectivity or intermittent connectivity jurisdictions and regions? That would be really cool. And there are some companies that have explored those options, but I think more work is necessary to really begin to open up access in places like that. Would be super cool to kind of where we've come so far with a bunch of the assets that we have, and starting to implement those services and those toolings and those capabilities into locations that could benefit the most from them, rather than just like rebuilding, hey, I know you already have Cash App, but here's a version of it on the blockchain. Maybe that's cool. But there's whole swaths of the world that don't have access, don't even have the hope of using something like a Cash App or a Venmo or a PayPal. And because we have blockchain technology and can connect these things instantly and so easily in a distributed network, all those things are possible. But are they still blocked out just by the fact of they don't have instant, fast or immediate and fast internet. There's explorations that need to happen on that front. Good questions, though. All right, well, that looks like we're about out of time. I don't see any other questions. The Discord is still open. There's a channel for Stellar if y'all have continued questions. I'm going to paste a few of these links to the projects that we talked about, as well as a couple of the other delegated signing products that are out there. As y'all need inspiration or have other questions, feel free to reach out. Otherwise, this has been fun. I appreciate your time. Look forward to seeing what you all build. We'll catch you later. Bye.